here we have a rather difficult set of equations. We have real numbers a, b, and c such that their sum is equal to 2 and the sum of their squares is equal to 12. We need to find the difference between the maximum and minimum value of c. If you know the Cauchy-Schwarz inequality, this question is actually very simple. However, this is the AMC test, and the Cauchy-Schwarz inequality is only used, well, not only used, but mainly used in Olympiad level proofs. So a lot of students probably don't know that inequality. So that means that there has to be another way in order to solve this that doesn't rely on such advanced techniques. And this is the way to do it. So the first thing you can notice is that these variables are all symmetric, meaning one doesn't hold any more weight than the other. It isn't a plus 3b plus 4c equals 2. It's a plus b plus c equals 2. So that means you can kind of switch them with each other, and it'll be the same thing. So that will probably come in handy later. But in the meantime, let's solve for c and see if we can just get rid of c. Because as we said, the variables are symmetric. So if we find the minimum and maximum values of, say, b, and then we pretty much have already found the minimum and maximum values of c. So solving for c, we get 2 minus a minus b in this first equation, solving for c. And then plugging this into the second equation, we get this, a squared plus b squared plus 2 minus a minus b squared equals 12. And then simplifying all that mess, you get this, and then a squared plus b squared minus 2ab minus 2a minus 2b plus ab equals 4. Wow, so now you have two variables, and what you have to do now is this rather common AMC trick in which even though you have two variables, you make a quadratic equation out of it. Now it is true that the quadratic equation only assumes that there's one variable, which is exactly what we have to do here also. We have to assume that one of these variables, a or b, is not a variable, is just a constant. And in this case, we can just assume that a is the variable and b is the constant. So in that case, you get a squared plus b minus 2a plus the constant term, b squared minus 2b minus 4. Note the resemblance of this with this, ax squared plus bx plus c. The a in this ax squared is just 1, right? That's just the coefficient. The b in the bx is just b minus 2 here. And the c, the constant term, is b squared minus 2b minus 4. Because remember, b is a constant in this scenario. That's what we're saying. And now we are going to use the discriminant, mainly because of this greater than or equal to sign. What this will give us is a way to pretty much put parameters on our values for our variables. So that way we can find maybe the maximum minimum values there. So the discriminant is b squared minus 4ac, and that's greater than or equal to 0. Keep in mind I'm writing uppercase b, a, and c over here to not make it similar to this a, b, or c over there. And also remember that a, b, and c are all real numbers. So we want this value to be greater than or equal to 0. Because if it's less than 0, then that means we're going to get complex numbers for these variables, and we do not want that. Substituting here, we get capital B squared, or b minus 2 squared, minus 4 times a, which is just 1, remember, times c, the constant term, b squared minus 2b minus 4. That's greater than or equal to 0. After some simplifying, you get this, and finally factoring it into this. You get minus 3b plus 10 times b plus 2 is greater than or equal to 0. And now we just have to solve for each parenthesis expression. You get minus 3b plus 10 is greater than or equal to 0. And solving for b, you get b is less than or equal to 10 thirds. For here, it's just b is greater than or equal to negative 2. So that means we can lock b into these parameters, negative 2 and 10 thirds. B has to be in between these two numbers. However, even though it may seem like we've just wasted a bunch of time finding b when we have to find c, keep in mind that these are all still symmetric equations. Remember how I said we can switch out one variable with the other when it comes to looking for the parameters of what those variables can evaluate to? So we switch the b for a c, which is perfectly fine in this scenario since one variable doesn't hold any weight over the other, and we get that c has to be in between negative 2 and 10 thirds. Therefore, we just have to find the difference between this maximum value and this minimum value. You get 10 minus minus 2, or 10 thirds minus minus 2. minus 2, 10 thirds minus 2, or 10 thirds plus 6 thirds, or 16 thirds. And that is the answer to this question, the difference between the maximum and minimum values of C.